Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dr. Jr., your math tutor and instructor at the University of Liberia. So in today's video, we want to look at finding the derivative of a function using the first principle of derivative or the definition of derivative. And example number 6 is to find the derivative of sine of x using the first principle. So we say f of x is equal to sine of x. So whenever we see f of x, we're going to replace it with sine of x. So the next thing we need is f of x plus h. So we use the same function. It's like saying f of x equals sine of x. So whenever we see x, we erase it and put x plus h so that it resembles this. And we take this one from there as well and put x plus h. So we've now gotten f of x and f of x plus h. So we can replace it in there. So we have f prime of x is equal to the limit of f of x plus h minus f of x all divided by h. H approaches 0. So this now will be f of x plus h is just sine of x plus h minus sine of x as h approaches 0. So our duty now is to expand this expression, sine of x plus h. So we know that from the sign of a sum identity, we know that sine of x plus h or sine of a plus b, whatever the case might be, as long as there are two angles in there, you will have sine of x cos of h plus sine of h cos of x. So this is the expansion for this one. Minus sine of x divided by h as h is approaching 0. Now, in addition to this property, let's also have the limit of sine of x all over x as x approaches 0 is equals to 1. The limit of 1 minus cos of h all over h approaches 0 is equals to 0. And also the limit of 1 cos of h minus 1 all over h as h approaches 0 is equals to 0. So let's maintain h because we're dealing with h here. So you can check my videos on YouTube relative to limits involving trigonometric functions. All of these were proven. So please check my videos on YouTube. Just Google Peter C. Dr. Jr. or you can directly go to YouTube and search for Peter C. Dr. Jr. So take note of those ones as well because we're going to use them. So now we have f prime of x. So at this point now, we want to group because we want to bring in either this property or this property or this property. So we want to group. Now look at the first and the second term. Is there anything in common? There is nothing in common. But the first and the last term, sine of x is in common. Is common to the two of them, right? So if we factor out sine of x, it means we have cos of h minus 1. Cos of h minus 1 divided by h will give us 0. So we can pair sine of x cos of h minus sine of x. Right? We pair this one plus sine of h cos of x. Pair these two. So we express this one over h. We express this one over h. It's the same thing. h approaching 0. So we can independently take the limit of this expression and this expression. So we take the limit of this one. Remember, we can factor out sine of x, and then cos of h remains minus 1 because you are factor out sine of x, divided by h as h approaching 0. We can also take the limit on this side, the limit of sine of h cos of x all over h. H approaches 0. Now I want you to take notice of something. Note that sine of x is a constant because the variable here is h. So any other variable within this function becomes a constant. So sine of x is a constant. So we can factor out sine of x. So we'll be left with the limit of cos of h minus 1 all over h as h approaches 0. So if we look there, this expression that we gave you is equal to 0. So a sine of x times 0, this whole thing go out, right? Plus the limit of, now also cos of x is 0. So we can factor out cos of x. And then we'll just be left with sine of h all over h as h approaches 0. So according to the squeezing theorem, this whole expression is just equal to 1. So you got cos of x times 1. Thus, the derivative of sine of x is just equals to cos of x. So thanks ever so much for watching. See you next class.